Hi, it's Rob. Welcome to the next video in the Cumulus Cycles Amazon Lex playlist, where we'll use Lambda to validate slot data. If you followed along in the prior video, you'll recall that we built the Burger Buddy bot, which allowed a user to order burgers, drinks, and sides. In this video, I'll be using a slightly modified version of that bot, which allows a user to order burgers, but no sides or drinks. I did this to simplify the implementation. However, the slot validation we implement in Lambda can be modified to also validate drinks and sides if you'd like to enhance this project. So, to get started, let's take a look at the current version of the Burger Buddy bot, its intent, and slots that we'll be working with. Starting with the slot types, we'll see we have three: burger sizes, burger types, and burger franchises. Burger sizes are the same sizes we used in the prior video: single, double, or triple patty. The burger franchises slot also has the same values from the prior video: best burger, burger palace, and flaming burger. And the burger type slot consists of all the burger types for the burger franchises we used in the prior video. Now, taking a look at the intent, we see we have the order burger intent. It has 4 sample utterances. The first, I'd like to order a burger. Then, I'd like to order a burger type. I'd like to order a burger size burger type. And finally, I'd like to order a burger size burger type from a specific burger franchise. The prompt for the burger size slot asks the user which size burger they'd like, a single, double, or triple patty. The burger franchise slot prompts the user to indicate where they'd like to order from: best burger, burger palace, or flaming burger. And the burger type slot prompt asks the user what type of burger they would like and gives examples of a cheeseburger, a fried egg burger, or a jalapeno burger. The confirmation prompt asks the user if they'd like the bot to order their burger size, burger type from their burger franchise. If the user confirms the order, the fulfillment message will indicate that the bot has ordered their burger size burger from the burger franchise. Else, if the user declines the confirmation prompt, they'll receive a message: "Stay hungry, my friend." Now, having walked through the intent, let's go ahead and test it out. So I'll start with the utterance: "I'd like to order a burger." And I'm prompted to indicate which size burger I'd like. I'll start with a single. Then, where would I like to order from? I'll order from Best Burger. And then I'm asked what type of burger I'd like to order. Examples are cheeseburger, fried egg burger, or jalapeno burger. And I'll go ahead and order a cheeseburger because I know that this is a Best Burger type of burger. And finally, would you like me to order your single cheeseburger from Best Burger? And I'll say yes. And the fulfillment message indicates that the bot has ordered my single cheeseburger from Best Burger. Now, let's go ahead and clear this and test with a different utterance, where I'd like to order a double chili burger from Flaming Burger. And here, the bot asks if it would like me to order their double chili burger from Flaming Burger. In this case, I'll say no, and I get the message: "Stay hungry, my friend." Now, in this test case, you'll notice that we weren't prompted to provide data for the slots. And this is because we provided all the data, the burger size, the burger type, and the burger franchise, in our initial utterance. Had we left out any of that slot data, the bot would have prompted us for it before asking if we'd like it to order and then providing the fulfillment message. So in this state, it looks like the bot is working fine with the intent, the slots, and the messaging. However, let's do one more test. Here, I'll tell the bot I'd like to order a burger. It'll ask me which size. I'll go with single. And where would I like to order from? In this case, I'll say Best Burger. And then it asks me which type of burger I'd like. And again, I'll go with a chili burger. and it asks me, would you like me to order your single chili burger from Best Burger? Now, this looks like it's okay, but the problem is that Best Burger doesn't offer chili burgers. Chili burgers come from Flaming Burger. So here I'll say no, but now we need a way to validate that user input. So if the user tries to order a chili burger from Best Burger or a cheeseburger from Flaming Burger, we don't allow the bot to move forward, and we prompt the user for proper data. And to do that, we'll use Lambda. Okay, so here I am over in the AWS Lambda console, and I'll start by creating a new function. I'll author it from scratch. I'll give it a name of Burger Buddy Order, and it'll be written in Python. Now I'll scroll down and create the function. And here we have our default Lambda handler. So what I'm going to do here is just print out the event so that we'll be able to see what's being passed to Lambda from Lex. I'll go ahead and save this and deploy it. Then let's jump back over to Lex. And now we need a way to tell Lex to use the Lambda function for validation. So the first thing we'll do is scroll down to the bottom of the intent and check the checkbox under code hooks to use a Lambda function for initialization and validation. Then I'll scroll up to confirmation and expand this. Then click Advanced Options, scroll to the bottom, and under Dialog Code Hook, I'll expand this and click the checkbox to invoke Lambda function. And make sure that this is active. So I'll go ahead and update the options. And then ultimately, we're going to use the Lambda function for fulfillment. So while I'm here, I'll expand this, click Advanced Options again, and this time at the top, click the checkbox to use a Lambda function for fulfillment, and then update the options. Now I'll save the intent and rebuild. Okay, with the bot rebuilt, we can go ahead and test. But before I enter my utterance, I'm going to click the gear icon, and then under Lambda function, I'll select the Burger Buddy order for the source and the latest version. I'll go ahead and save. And now I'll enter my utterance of, I'd like to order a burger. And before I hit enter, I'm going to click inspect. And here we'll be able to see the data that we send in the slot, as well as the JSON input and output. Okay, so I'll come back over here and hit enter. And we see we get an invalid response from Lambda. So we were definitely able to send this data from Lex to Lambda, but we're getting an invalid response because all our Lambda function is doing right now is returning the status coded 200 and the body hello from Lambda. And if I click on JSON input and output, we'll see in the request, here's the text, I'd like to order a burger, and the error response, invalid message from Lambda, and the rest of the text that we see here. So let's jump over to Lambda. I'll click on monitor and view logs in CloudWatch. Go into our log stream. And here, if I expand this, we'll see the data that was submitted from Lex. Now I'm going to go ahead and copy this and so we can format it and take a better look at it. Okay, so here I've pasted the request into a data.py file, and it's formatted so we can take a better look at it. And we see some properties. So a session ID is sent. The input transcript is, I'd like to order a burger. There's a section called interpretations, which we're not going to look at right now. We'll skip proposed next state. And in session state, we'll see that right now there are no session attributes sent, but we see an intent property. And under intent, we have our slots of burger size, burger franchise, and burger type, all with the values of none, because all we did was input the utterance, I'd like to order a burger. We didn't give a burger size, a burger franchise, or a burger type. And we weren't prompted by Lex to provide the slot data because we're not handling it properly in the Lambda function. And because we're using a Lambda function for validation, it's not following the default conversation flow that we had seen previously in Lex. So the next thing we're going to do is jump into Lambda and start implementing code so that the data that we submit for Lambda for validation will be handled properly in Lambda, and Lambda will send an appropriate message back to Lex to handle the conversation flow. However, before we head back to Lambda, I want to look at the documentation for using an AWS Lambda function in Lex. And specifically, I want to jump down to the session state. And the session state is the current state of the conversation between the user and the bot. If we scroll down, again, we'll see the intent property with the slots and then the slots with their values. But another property I want to point out here is the dialog action. And the dialog action indicates the next action Lex should take. And there are two dialog action types that we'll be using in this demo: delegate and elicit slot. Now, the delegate dialog action is when Lambda delegates the action to Lex. So it tells Lex, hey, everything looks good here, so take the next step in the conversation flow. The elicit slot is when Lambda tells Lex which slot should be processed for additional user data. So if Lex sends data over to Lambda and something is either missing or doesn't look right, Lambda will tell Lex, hey, go get the data from the user for the slot that I send you in the elicit slot. The last property I'd like to look at is invocation source, and it could be dialog code hook or fulfillment code hook. And this invocation source indicates the action from Lex that called this Lambda function. When the source is a dialog code hook, that means the Lambda function was called after input was provided from the user. And when the source is the fulfillment code hook, then the Lambda function was called after all the required slot data had been entered and the intent is now ready for fulfillment. Now, if we jump back into that response data that we copied, right, again, here's our session state, here's the intent, here's the slots, and the slots with the data, which as we saw before is currently none. And if I search for invocation source, we see that the invocation source for this request was from a dialog code hook. And that's because the Lambda function was called after input from the user. And the input in this particular case was submission of the utterance. Okay, so now that we have an understanding of the session state, the dialog actions, and the invocation source, let's head back over to Lambda and start adding some code to properly interact with Lex. Okay, so back in Lambda, the first thing I'm going to do is add some variables for the bot name, the slots, and the intent name. The slots and the intent name, as we saw previously, will come from the session state. The slots will come from the intent property of the session state, and the intent will come from the name property of the intent on the session state. In the event, there's a bot property with a name, and that's what we'll use to get the bot. And for now, I'll just print those out so we could take a look at them in CloudWatch. So I'll go ahead and deploy this, go back to Lex, and test again. Now, of course, we get the same response, but if we go back to CloudWatch and go into our log stream, now we see, in addition to the original event that we were printing out, we see the bot name, the slots, and the intent. Okay, so now we're able to pull data that we need out of the event. All right, to go through the rest of the Lambda function code, I'm going to use VS Code because I think it's easier to see than looking at it in the Lambda console. So here we'll start in the Lambda handler again. What I want to do is create a variable, and I'll give it a name of order validation result, and set it equal to calling a validate order function we'll create, passing it the slots. Here on line 10, I've created that function, and what we want to do in here is validate the burger size slot data, validate the burger franchise slot data, validate the burger type slot data, and finally validate that the burger type slot data is correct for the burger franchise slot data. And in order to do that, I've created these variables with the appropriate burger size, burger franchise, and burger types for the burger franchise's data. Down in the validate order function, the first thing I want to do is check to see if the user passed a burger size in the burger size slot. If not, then I'll return an object setting the isValid property to false and the invalid slot to burger size. Then what I want to do is check to see if they did pass a burger size, if the value that they passed is not in the burger size's data. So if they passed a burger size that isn't a single, double, or triple, then in our return object, again, we'll set isValid to false. The invalid slot will be burger size, and we'll pass a message asking them to please select an appropriate burger size, listing the values in the burger sizes variable. We'll do something similar when we validate the burger franchise. We'll check to see if they pass data in the burger franchise slot. If not, isValid will be false, and of course the invalid slot will be the burger franchise. Again, we'll check to see if the value that they passed in the burger franchise is not in burger franchises, and if that's the case, of course, the invalid slot will be set to burger franchise again, and this time we'll pass a message asking them to select from the burger franchises. To validate the burger type, we'll just check to ensure that they passed a value in the burger type slot. If not, isValid is false, and the invalid slot is burger type. Now, the last validation we want to do is to ensure that the type of burger that they pass is the appropriate burger for the franchise. So in this case, we're checking to see if the burger franchise is equal to best burger. And if it is, we'll check to see if the value for the burger type is not in the best burger types. So if they didn't pass a value that was plain, cheese, or bacon in the burger type slot, we'll return an object, of course setting isValid to false. The invalid slot will be burger type, and the message will be, please select a best burger type of, listing the best burger types. The same type of validation will hold for the Burger Palace franchise and the Flaming Burger franchise. Now, if any of the validations above produce invalid results, we're returning an object with the properties. If all of the validations pass, then we'll return an object with isValid set to true. So now that we have the result in the order validation result variable, what we want to do is check to see what the invocation source is. And again, it could either be dialog code hook if the invocation source is being invoked as a result of the user submitting data, in which the bot will call Lambda. If the invocation source is the fulfillment code hook, as you'll remember, this means that all the slot data validations have passed and we're ready to fulfill the order. So in our case, we're currently in the dialog code hook invocation source. So what I'm going to do is check to see if not, order validation result is valid. And if it's the case that the order validation results is valid value is not true, then we'll check to see if a message was sent in the order validation result. And if that's the case, when we build the response in the session state, we'll set the dialog actions slot to elicit property equal to the invalid slot that we set above. And as an example, the invalid slot here is burger type. And the dialog actions type will be elicit slot. So basically, we're going to send this back to Lex, indicating that this was an elicit slot action, and the slot was the slot that we're passing here. We'll pass back the name of the intent and the slots, and the message, which will be in plain text, and its content value will be the message that's returned as a result of calling the validate order function. Else, if there is no message, in a response, we'll return the same dialog action property values and intent properties, but no message. And if it's not the case that this evaluates true, then the response will have the session state's dialog action equal to type delegate, which will tell Lex, hey, all the data that was passed in this dialog code hook was valid, so I'm going to delegate the next action to take to you. Then jumping down and looking at the code for the fulfillment code hook invocation source, we'll build a response object with a session state setting the dialog action type to close. And this will close the conversation flow in Lex. Okay, so let's go ahead and copy all this code and jump back over to Lambda, paste it in, and deploy. Now we can jump back over to Lex, we'll clear, and test it out. So we'll start again with, I'd like to order a burger. And this time we get the response back, what size burger would you like? Single, double, or triple patty? And if we look over at the inspect tab, we'll see that in our slots, we did pass a burger franchise, a burger size, and a burger type slot, but there were no values. Which makes sense because we didn't include them in our utterance. And if we look at the JSON input and output, again for the request, we'll see the text, I'd like to order a burger. And if we scroll down and look at the response, and we see the message comes back, what size burger would you like? Remember, we set the session state's dialog action type to elicit slot and indicated that the slot to elicit is the burger size. And that's what we're being prompted for now. So I'll go ahead and say single. And I'm prompted, where would you like to order your burger from? And then the list of burger franchises is presented. And over in the inspection summary, we see that under the burger size slot, we pass the value of single. And in the JSON input and output, we scroll down to our request. Here we pass the text of single. And in the response, we see the content of where would you like to order your burger from, with the slot to elicit being the burger franchise slot. So I'll go ahead and say best burger. And now I'm asked for the type of burger I'd like to order. If we look at the summary, this time in our slots, we have the burger size, which is single, and the burger franchise of best burger. So here I'll go ahead and order cheese, because I know this is a proper best burger type of burger. And I get my final prompt of, would you like me to order your single cheese from Best Burger? I'll say yes. And we're presented with the fulfillment message. And if we scroll down on the left here inside of the bot, we'll see that our original fulfillment message was, I've placed your order for a burger size, burger type from burger franchise. But in the Lambda function, we're returning a fulfillment message of, I've placed your order. And I did this just to differentiate between the two fulfillment messages so that we could see that the processing is now being done by Lambda. All right, so this is looking pretty good, but let's run a couple more tests just to make sure we've covered all our bases. So I'll clear this out. And this time I'll run a test saying I'd like to order a burger. And what I'm ultimately going to do is order an incorrect burger type from a burger franchise. Okay, so I've submitted the utterance, I'd like to order a burger. There was no data passed in the slots, and I'm prompted to indicate what size burger I'd like. This time I'll go with a double, which you see was passed in the burger size slot. And where would I like to order from? So again, I'll say best burger. And we see again that's passed in the burger franchise. Now which type of burger? So instead of ordering a proper best burger type of burger, I'm going to order a jalapeno burger, which is a flaming burger type of burger. And we see we passed jalapeno as the burger type slot data, and now we're prompted to please select a best burger type of burger, either plain cheese or bacon. So this time I'll go with bacon. We see the burger type slot data was updated, and the bot asks me if it would like me to order the burger. So this time I'll say no, and I see the confirmation decline message of stay hungry, my friend. For a final test, I'll enter the utterance, I'd like to order a triple jalapeno burger from Flaming Burger. I'll go ahead and submit this. And we see the values were sent in the appropriate slots. And now the bot straight away asks me, would you like me to order your triple jalapeno from Flaming Burger? I'll say yes. And now the bot has placed my order. So that concludes this video on validating Lex slot data with Lambda. If you found it useful, feel free to give it a like. And if you'd like to be notified when I add more content, please consider subscribing to the channel. In the next video, we'll integrate our chatbot into a web page hosted in S3. Thanks for watching.